You have other threat intelligence research sources. The academic journals are there. Okay, results from the academic researchers and non-for-profit trade bodies or associations like IEEE. Okay, they published papers and journals over there. You can go for conferences, okay, security conferences that are hosted and sponsored by various institutions and provided an opportunity for the presenters on the latest threats, presentations on the latest threats and technologies. RFC is there, request for comments. Okay, when a new technology is accepted as a web standard, it is published as an RFC by W3C. Okay, and the social media is there. Companies and individual researchers and practitioners write informative blogs on social media feeds. Okay, so we can get plenty of information, or you can say plenty of intelligence from these different sources, where we have IBM X-Force Exchange vendor website provided by different tools over there. Okay, public and private information sharing centers, ISACs, information sharing and analysis centers, and the open source intelligence. Okay, for the reconnaissance and the monitoring, you can have the tools over there, and you can use those tools. Okay, we can get the information from the academic journals, conferences, request for comments, and the social media. The threat intelligence information we can get from these sources. These are basically the providers of the information. Okay, if you want to research by your own, you can go for these things. Okay, you can have your own honeypot and honey nets over there. You can search on the dark web and the darknet. Okay. Then it comes to the TTPs, the tactics, techniques, and the procedures, and with that, the indicator of compromise. The tactics, techniques, and the procedure is basically a generalized statement of adversary behavior. Okay, it is basically it categorizes the behaviors in terms of the campaign strategy. Okay, that is the campaign strategy, and the approach, that is the tactic. The generalized attack vectors, these are the techniques, and the specific intrusion tools and the methods are the procedures over there. Okay, the indicators of compromise, it's basically is a residual sign that an asset or a network has been successfully attacked or is continuing to be attacked. Okay, it's basically the evidence of TTP. Okay. Now, IOCs can be of many types, like can say the unauthorized softwares in the files over there, or the suspicious emails, or unknown ports and protocol usage, or file system changes, the suspicious file system changes, the suspicious registry changes over there. Okay, service disruption, defacement. Okay, so those kind of indicators. These are the indicator of compromise that we can look for. Okay, and the IOCs can be definite and objectively identifiable. Like for example, a malware. Okay, for a malware, you can see the malware signature. Okay, you'll be able to find out. Okay, you can go and analyze the malware, and then you can see that, okay, what exactly the malware is doing. Okay, on which IP address the malware is trying to make the communication. Okay, on which port number the malware is trying to make the communication, what registry changes the malware is doing, what file system changes the malware is doing. That is basically correlation of the system and the threat data. Okay, now the threat intelligence platforms that we have, okay, those are the AI backed okay, they use the AI backed analysis to speed up the detection without overwhelming the analyst's time with the false positives. Okay, and they easily can find out the indicator of attacks also. Okay, it's basically again it's also used for the evidence of an intrusion attempt and progress. Okay, So compromise, indicator of compromise will give you the information that, okay, the system is successfully attacked or continuing to be attacked. And this term is used for continuing to be attacked, for example. Okay, the intrusion attempt in progress, for example. Okay. Then you have the threat data feeds. Okay, when you use the cyber threat intelligence platform, okay, you will subscribe to a threat data feed. Okay, and the information in the threat data can be combined with the event data from your own network and the system logs. Okay, the analysis platform will perform the correlation to detect whether any indicator of compromise present, and there are various ways that a threat data feed can be implemented. Okay, Sticks is one of them. Okay, structured threat information expression. Okay, this is OSIS CTI framework, the open source, that is designed to provide a format for this type of automated feed, so that the organization can share the CTI. Okay, it's a part of the framework that describes the standard terminology for the indicator of compromise and the ways of indicating the relationship between them. Okay, where the sticks provides the syntax of describing the CTI. Okay, the trusted automated exchange of indicator information is there. That is basically the protocol. The taxi is a protocol that provides a means of transmitting the CTI data between the server and client. Okay, like for example, a CTI service provider will maintain a CTI, the repository of the CTI data. Okay, the cyber threat intelligence data. Subscribers will subscribers to the service will obtain the updates to the data to load into the analysis tools over the taxi. Okay, and then the data can be requested by the client, or the data can be pushed to the subscriber. Okay, then you have the automated indicator sharing. Okay, that is basically the service offered by the Department of Homeland Security, DHS. Okay, for the companies to participate in the threat intelligence sharing. Okay, and it is specially aimed at ISACs. Okay, information intelligence sharing and analysis centers, but provide the companies to, but private companies can join too. Okay, and AIS is based on the sticks and the taxi standards or protocols. Okay, then threat maps are there, the animated graphics showing the source, target, and the types of attacks that have been detected by the CTI platform. Okay, the security solution provider published these kind of maps showing the global attacks on their customers' system. Okay, files and code repository is there. Okay, just like the virus total that holds a signature of the known malware code. The code samples derived from the live customer system and the files that have been uploaded by the subscriber. Okay, and then you have the vulnerability databases and the vulnerability feeds. Okay, for the vulnerability databases, you can go for NVD, National Vulnerability Database by NIST. Okay, you can go for CVE dot by MITRE. Okay, the common vulnerability and exposure. This will give you the list of the vulnerabilities. NVD also will give you the list of vulnerabilities with their, severity level and the solutions over there. Same goes with the CVE also. Okay. Then you have the artificial intelligence and the predictive analysis. Okay. Now, artificial intelligence basically is the science of creating machine systems that can simulate or demonstrate a similar general intelligence capability to the humans. Okay. Early types of AI systems are the expert systems. Okay. Use if-then rules to draw the inferences from the limited data sets, from the knowledge base, basically. Okay. Then they introduced machine learning over there that uses the algorithm to parse the input and then develop the strategies for using the data, using that data, like identifying an object as a type, working out the next move in a game, right? That kind of things. Okay, unlike the expert system, machine learning can modify the algorithms that it uses to pass the data and develop the strategies, and it can make the gradual improvement in the decision making process. Okay, and the structure that facilitate this learning process is artificial neural network. Okay, the nodes in the neural network take the input and then derive the output. Okay, using the complex feedback loops between the nodes. Okay, and in the ML system has the objectives and the error states, and it adjusts its neural network to reduce the errors and optimize the objectives out there. Okay, then it comes to the predictive analysis, that is basically identifying the signs of past attack or the presence of live attack tools on a network quickly is valuable. Okay, one of the goals of AI-backed threat intelligence is to perform the predictive analysis or threat forecasting over there. Okay, I mean, the system that can anticipate a particular type of attack and possibly the identity of a threat actor before the attack is fully realized. Okay, and the analysis engine also associated with the chatter, with the IP address that it can correlate with a known adversary group. Okay, and this basically gives the advanced warning that an attack is in the planning stages, and the more time to prepare an effective defense over there. Okay, any confusion till now? This is basically the end of the lesson number 2. Okay, where we discussed about some of the threat actors.
Can I grab one more thing off that last slide? I'm sorry. Predictive analysis. I'm sorry.
This one, yeah. So you want to understand the predictive analysis.
What do you mean by chatter exactly? Like talking.
Like, for example, the system, system that are, for the company, okay, for a company, okay, the related IP addresses for a company, the web, the account names across the range of data from the dark web sources or the web searches or the social media posts or phishing email attempts. Okay, so those